China enters the supersonic race with the C949 jet, a comprehensive overview. On March 30, 2025, China officially announced its entry into the competitive arena of supersonic aviation with the unveiling of its new passenger jet, the C949. Developed by the state-owned China Commercial Aircraft Corporation Comac, the C949 is poised to challenge the legacy of the iconic Concorde, which was retired in 2003. The announcement marks a significant milestone in the global aerospace landscape, igniting a renewed competition primarily with U.S. aviation manufacturers. Key features of the C949. The C949 is designed to fly at speeds of 1.6 Mach, which is approximately 1,227 miles per hour, and boasts an impressive range of 11,000 kilometers, about 6,800 miles. This range enables potential non-stop flights from major cities in Europe to destinations in Asia, significantly exceeding the Concorde's maximum range of around 4,500 miles. One of the standout features of the C949 is its innovative design aimed at reducing noise pollution. The aircraft is engineered to produce sonic booms at a perceived level of 83.9 decibels, which is considerably lower than the 105 decibels produced by the Concorde. This reduction is achieved through a reverse-camber fuselage design, which minimizes shock waves and could potentially allow the C949 to circumvent existing regulatory barriers that have historically restricted overland supersonic flights. The aircraft is designed to accommodate 168 passengers, surpassing the Concorde's capacity of 128. Additionally, the C949 is intended to operate more quietly and efficiently, making it a more appealing option for airlines and passengers alike. Context of the supersonic race. China's venture into supersonic travel is part of a broader global trend toward reviving commercial supersonic aviation, which had been dormant since the retirement of the Concorde. Several U.S. companies, including Boom Supersonic and Spike Aerospace, are also developing their own supersonic aircraft. Boom Supersonic's XB-1 prototype has already conducted successful test flights, achieving speeds of Mach 1.7 and a range of 4,888 miles. Spike Aerospace is developing the S512, designed to fly at 1.6 Mach with a range of 7,100 miles, albeit with a significantly smaller passenger capacity of only 18. Other notable projects include NASA and Lockheed Martin's X-59, which aims to achieve supersonic speeds while minimizing noise. The competitive landscape is rapidly evolving, with numerous players vying to establish themselves as leaders in the next generation of commercial air travel. Timeline and future prospects. The development of the C949 is ambitious, with Comac aiming to have the aircraft operational by 2049, coinciding with the 100th anniversary of the People's Republic of China. This timeline reflects China's strategic goal of positioning itself as a global leader in aerospace technology. In contrast, Boom Supersonic has already secured multiple orders for its Overture jet and conducted successful test flights in early 2025, indicating a more immediate push toward bringing supersonic travel back to the commercial sector. Concerns and implications. The entrance of China into the supersonic race raises several concerns, particularly regarding the dual-use potential of supersonic technology for military applications. Comac's ties to the Chinese government and military have led to sanctions from the U.S. government, which could complicate international collaborations and raise geopolitical tensions. Blake Scholl, CEO of Boom Supersonic, acknowledged the competitive nature of the situation, stating on social media, folks, it's no surprise, but China has now officially entered the supersonic race. Game on. Let's beat 'em. Conclusion. China's unveiling of the C949 represents a significant development in the aerospace industry, signaling a robust commitment to advancing supersonic passenger travel. As the competition heats up between China and the United States, the future of commercial aviation could witness a transformation characterized by speed and efficiency. The C949's innovative design and ambitious timelines suggest that China is not merely participating in the race but is aiming for a leadership position in the next era of air travel. In this high-stakes environment, the technological advancements and strategic decisions made by each player will shape the future of global aviation for years to come. 1. China's entry into supersonic aviation. The introduction of the C949 marks a significant moment in aviation history as it signifies China's commitment to leading in advanced aerospace technology. This move is not just a technological endeavor but also a strategic one, positioning China as a competitor to the United States in a sector historically dominated by Western aerospace companies. 2. Performance metrics. The C949 is designed to fly at 1.6 times the speed of sound, Mach 1.6, with a range of 11,000 kilometers, approximately 6,800 miles. This is counterintuitive considering that most new aviation projects typically aim for both speed and range improvements, yet the C949 sacrifices maximum speed for a greater range and quieter operations compared to its predecessor, the Concorde. 3. Noise reduction technology. The C949 sonic boom is expected to be significantly quieter at 83.9 decibels compared to the Concorde's 105 decibels. This is achieved through a reverse-camber fuselage design that minimizes shock waves. This aspect is particularly surprising because many past efforts to develop supersonic technology have struggled with noise issues which have historically limited supersonic flights over land. 4. Passenger capacity. The C949 can accommodate 168 passengers, which is a substantial increase from the Concorde's capacity of 128. This reflects a counterintuitive trend in aviation where newer aircraft often emphasize passenger comfort and capacity alongside speed, challenging the notion that supersonic jets must cater to a niche market. 5. Regulatory challenges. The design aims to bypass regulatory restrictions that have historically prohibited overland supersonic flights due to noise complaints. This is a critical pivot as it suggests that technological advancements may outpace existing regulations, leading to potential shifts in aviation policy. 6. Military concerns. The potential dual use of supersonic technology for military applications raises eyebrows, particularly with Comac's ties to the Chinese government and military. This reflects a broader, often overlooked aspect of aerospace development where advancements in commercial aviation can have unintended military implications. 7. Competitive landscape. While U.S. companies like Boom Supersonic and Spike Aerospace work on their own supersonic projects, the C949's introduction adds a layer of competition that many did not anticipate from China so soon. U.S. companies have positioned themselves as the leaders in this field, making China's entry a surprising twist in the narrative of aerospace innovation. 8. Historical context. The timing of the C949's planned operational debut in 2049 coincides with the 100th anniversary of the People's Republic of China, which is a strategic move intended to showcase China's advancements in technology on a significant national milestone. 9. Comparison with other technologies. The mention of competing technologies such as NASA and Lockheed Martin's X-59 highlights a counterintuitive aspect of the race towards supersonic travel. Multiple countries are developing similar technologies, suggesting that the future of aviation might not lie with a single dominant player but rather a variety of approaches that could redefine commercial and military aviation. 10. Broader implications. The advancements in supersonic travel, particularly with the C949, could lead to a renaissance in air travel, challenging the status quo of economic and environmental constraints that have plagued the aviation industry. This reflects a counterintuitive perspective that rapid advancements in technology can sometimes occur despite historical setbacks and challenges. In conclusion, the development of the C949 supersonic jet by China not only signifies a technological leap but also embodies the complexities of global competition in aerospace, regulatory challenges, and the intertwining of commercial and military interests. The report on China's entry into the supersonic jet race with its new aircraft, the C949, is packed with significant details that many readers may overlook. These details not only highlight the technological advancements and competitive landscape of the aerospace industry but also point to broader implications for international relations, environmental regulation, and the future of air travel. 1. technical innovations in sonic boom reduction. One of the most noteworthy aspects of the C949 is its design innovations aimed at reducing sonic booms. The aircraft is engineered with a reverse-camber fuselage which is said to minimize the shock waves produced when the aircraft exceeds the speed of sound. This engineering feat is critical as it addresses one of the primary regulatory hurdles that have historically limited supersonic travel over land. The sonic boom from the Concorde was measured at 105 decibels, which was disruptive enough to prevent overland flights in many regions. In contrast, the C949 sonic boom is expected to be around 83.9 decibels, comparable to the noise of a standard hairdryer. Significance: this shift in design not only showcases China's engineering capabilities but also has the potential to influence global aviation regulations. If the C949 can successfully operate over land without regulatory pushback, it could pave the way for a new era of supersonic travel, fundamentally changing how people perceive distance and travel time. 2. Strategic timing and national ambitions. The timeline for the C949's introduction, set to coincide with the 100th anniversary of the People's Republic of China in 2049, reflects a broader strategic ambition. This alignment may serve as a symbolic demonstration of China's technological prowess on a global stage, reinforcing its status as a leading power. Significance: the timing indicates that China's aerospace ambitions are not just about commercial gain but also about national pride and global standing. By aiming for such a milestone, China seeks to assert itself as a dominant player in a field that has historically been led by Western nations. This could shift global power dynamics in aviation and beyond. 3. Military dual-use concerns. A crucial yet often understated element of the discussion is the dual-use potential of supersonic technology. The report raises concerns about the military applications of such advancements, particularly given Comac's ties to the Chinese government and military. U.S. sanctions against Comac highlight this tension, suggesting that the development of the C949 is not merely an endeavor in commercial aviation but also part of a broader military strategy. Significance: this dual-use nature raises alarms in international relations, particularly for the United States and its allies, who may view advancements in supersonic technology as potential military threats. The implications extend beyond aviation, affecting arms control, defense spending, and diplomatic relations. Countries may be compelled to reassess their own aerospace programs and technologies in response to China's developments. 4. Environmental considerations and sustainability. The report emphasizes that the C949 is designed to be quieter and more efficient, which aligns with growing global concerns about environmental sustainability in aviation. The reduction in noise pollution is a significant step, but the report does not delve deeply into the environmental impact of supersonic travel regarding fuel consumption and emissions. Significance: as the world grapples with climate change, the aviation industry faces increasing scrutiny over its carbon footprint. The development of supersonic jets must balance speed and efficiency with environmental sustainability. If the C949 can demonstrate lower emissions compared to its predecessors, it could set a new standard for future aircraft designs. Conversely, if it fails to address these concerns, it may face backlash from environmental advocates and regulatory bodies. 5. Competitive landscape and market dynamics. The emergence of the C949 has ignited a competitive race with U.S. companies like Boom Supersonic and Spike Aerospace, which are also developing their own supersonic jets. Boom's XB-1 has already achieved significant milestones, and the company has secured orders from major airlines. Significance: this competition is not merely about technological superiority, it reflects broader economic interests and market dynamics. The outcome of this race could influence global aviation markets, investment in aerospace technologies, and even consumer preferences. Companies that successfully integrate advanced technology with marketable features such as comfort and speed will likely dominate the emerging supersonic travel market. 6. Cultural and historical context. The return of supersonic travel with the C949 also evokes historical sentiments, particularly relating to the Concorde. The Concorde's legacy is marked by both its technological marvel and its operational challenges, including safety incidents and economic viability. Significance: the cultural resonance of the Concorde may shape public perception of new supersonic jets. There may be nostalgia for the glamour associated with supersonic travel, but there will also be skepticism due to past failures. The C949 must navigate this historical context to successfully market itself to a new generation of travelers. Conclusion: the announcement of China's C949 Supersonic Jet is a watershed moment in aviation marked by significant technological innovations, strategic national ambitions, and implications for international relations. While the report touches on various aspects of the C949's development, the most critical elements, such as the implications of its quieter operation, the dual-use concerns, and the competitive dynamics, are often overlooked. Understanding these facets is essential for grasping the broader significance of China's ambitions in the aerospace sector and the future of global air travel. 1. Technological advancements in supersonic flight. The development of the C949 by China's Comac represents a significant leap in aerospace engineering, particularly in terms of speed, range, and noise reduction. With a top speed of 1.6 Mach and a range of 11,000 km, the C949 not only exceeds the capabilities of the retired Concorde but also introduces a reverse-camber fuselage design that significantly mitigates sonic boom intensity to 83.9 decibels. This advancement could potentially facilitate overland supersonic flights, which have been historically restricted due to noise concerns. The implications of this technology are profound, as they could redefine international air travel regulations and open new routes and markets for airlines. 2. Geopolitical and competitive dynamics. The unveiling of the C949 marks a pivotal moment in the aerospace landscape as it sets the stage for a competitive race between China and the United States to lead in supersonic passenger travel. Companies like Boom Supersonic and Spike Aerospace are also developing similar technologies, with Boom already having conducted successful test flights of its XB-1 prototype. This competition is not merely technological but also geopolitical, as advancements in aerospace capabilities are viewed through the lens of national security, particularly given Comac's ties to the Chinese government and military. The U.S. government's sanctions against Comac underscore the tension in this race, as each nation aims to assert its dominance in a critical sector of the economy. 3. Market demand and future of supersonic travel. The renewed interest in supersonic travel sparked by the C949 and its competitors reflects a broader market demand for faster and more efficient air travel options. The historical context of the Concorde's retirement due to safety and economic factors raises questions about the viability of new supersonic jets in a post-pandemic world where air travel is rebounding. With airlines already placing orders for new supersonic aircraft, the potential for profitability in this niche market is substantial. However, manufacturers must navigate not only technological challenges but also consumer perceptions and regulatory hurdles to successfully reintegrate supersonic travel into the mainstream market. 4. Environmental considerations and sustainability. As the new generation of supersonic aircraft emerges, environmental concerns surrounding fuel consumption and emissions are increasingly relevant. The C949's design aims to reduce noise pollution, but the aircraft's overall environmental impact will depend on its fuel efficiency and carbon footprint compared to subsonic alternatives. The aviation industry is under increasing pressure to adopt sustainable practices and technologies, making it imperative for new supersonic designs to align with global environmental goals. This aspect is crucial not only for regulatory compliance but also for public acceptance, as consumers are becoming more conscious of the environmental implications of air travel. In conclusion, the development of the C949 is a multifaceted issue that encompasses technological innovation, geopolitical competition, market dynamics, and environmental sustainability. Each of these points warrants in-depth analysis and discussion. as they collectively shape the future of supersonic passenger travel and its role in the global aviation landscape. 1. The Space Race 1957 to 1969. The space race was a competition between the United States and the Soviet Union during the Cold War to achieve significant milestones in space exploration. It began with the launch of Sputnik by the Soviet Union in 1957, which was the first artificial satellite to orbit the Earth. This event marked the start of intense competition in various aspects of aerospace technology, including satellite development, human spaceflight, and lunar exploration. The culmination of this race was the Apollo 11 mission in 1969, where the United States successfully landed astronauts Neil Armstrong and Buzz Aldrin on the Moon, making it a significant victory in the space race. 2. The race to develop the jet engine 1930s to 1940s. During the late 1930s and through World War II, several countries raced to develop jet engine technology, which would revolutionize air travel and military aviation. Pioneers like Frank Whittle in the United Kingdom and Hans von Ohain in Germany independently developed the first turbojet engines. The introduction of jet propulsion allowed aircraft to fly faster and at higher altitudes than ever before, leading to the development of iconic aircraft such as the British Gloster Meteor and the German Messerschmitt Me 262. The advancements in jet engine technology laid the groundwork for the future of commercial aviation. 3. The Supersonic Transport SST Project 1960s to 1970s. Following the success of the Concorde and the Soviet Tupolev Tu-144, there was a significant international effort to develop supersonic transport aircraft during the 1960s and 1970s. The Concorde, a British-French project, was the only SST to enter commercial service, flying from 1976 until 2003. The race to develop supersonic jets spurred technological advancements and set the stage for discussions about noise regulations, fuel efficiency, and environmental concerns that continue to influence aerospace design today. Despite the technological achievements, the Concorde's commercial viability was limited, leading to the eventual halt of supersonic passenger flights after its retirement. Future outlook: the supersonic race in aviation. The unveiling of China's C949 Supersonic Passenger Jet by Comac marks a significant moment in the global aviation landscape, igniting competition primarily against American firms like Boom Supersonic and Spike Aerospace. As the aerospace industry evolves, the future of supersonic travel appears poised for a revival, with several trends and predictions emerging from this competition. 1. Technological advancements and innovations. The C949 aims to fly at 1.6 times the speed of sound with a range of 11,000 kilometers, significantly surpassing the retired Concorde's capabilities. This advancement is indicative of a broader trend where companies are investing heavily in research and development. Innovations such as the reverse-camber fuselage design to reduce sonic booms are vital. Future aircraft may leverage advanced materials, improved aerodynamics, and alternative propulsion systems, enhancing efficiency and reducing environmental impacts. 2. Regulatory changes and overland supersonic flights. Historically, supersonic flights over land have been restricted due to noise concerns. However, with the C949's projected sonic boom levels comparable to a standard hairdryer, there is potential for regulatory frameworks to adapt. If successful, this could allow for overland supersonic routes, transforming travel dynamics and opening up new markets. Expect ongoing dialogues between manufacturers and regulators to evolve, possibly leading to relaxed restrictions in the next decade. 3. Environmental considerations and sustainability. As climate change becomes an increasingly pressing issue, the aviation industry faces scrutiny regarding its carbon footprint. Future supersonic jets will likely need to incorporate sustainable practices to meet environmental regulations and public expectations. This includes exploring alternative fuels and energy-efficient designs. Companies that prioritize sustainability in their development strategies might gain a competitive edge in a market increasingly concerned with ecological impacts. 4. Market demand and economic viability. The demand for faster travel is expected to rise, especially in a post-pandemic world where time efficiency has become paramount. Business travelers and affluent consumers may drive initial demand for supersonic flights. Airlines will need to assess economic viability, including ticket pricing and operational costs, to ensure profitability. A successful launch by one or more companies could spur interest and investment, leading to a more robust supersonic market by the 2030s. 5. Geopolitical implications and competition. China's entry into the supersonic race raises geopolitical concerns, particularly regarding technology transfer and military applications. As nations compete to dominate aerospace, innovation collaborations between private companies and government entities may intensify. The US and allies may respond with strategies to bolster their own aerospace industries, potentially leading to a technological arms race in aviation. The implications of this could extend beyond commercial aviation, influencing defense and space technologies. 6. Consumer experience and cabin innovations. Supersonic jets will not only need to focus on speed and efficiency but also on enhancing the passenger experience. Future designs may offer luxurious interiors and advanced connectivity, making long-haul flights more comfortable and productive. Companies like Spike Aerospace are already focusing on high-end experiences, which could set new standards in the industry. This emphasis on passenger comfort will likely be a key differentiator in the competitive landscape. 7. Integration of space and air travel. The future of aviation might not be limited to traditional flight paths. With companies exploring the concept of space-air hybrid vehicles, we might see a convergence of air travel and space exploration. This could open up new avenues for travel and transport, potentially allowing for intercontinental travel that bypasses traditional airspace constraints. Conclusion. The race towards a new era of supersonic travel is gaining momentum, driven by significant technological advancements, evolving regulatory landscapes, and a growing market demand for faster, more efficient travel. As companies like Comac, Boom Supersonic, and Spike Aerospace continue to innovate, the next decade could see the re-establishment of commercial supersonic flights, fundamentally changing the way we perceive and experience air travel. However, the road ahead will require careful navigation of environmental, regulatory, and competitive challenges, making the future of supersonic aviation an exciting and complex arena to watch.